thank you listeners to give so much love to this podcast. This podcast is brought to you by www.chemistrynotesinfo.com. In today's episode, we are going to learn classification of elements and periodicity in properties. This is a very important chapter for class 11th students. Mendeleev periodic law. Mendeleev explained that properties of the elements are periodic function of their atomic weights. Modern periodic law. This law is given by Moseley in 1913. According to this law, physical and chemical properties of the elements are periodic function of their atomic numbers. S block elements. Elements of group 1, that is alkali metals, with Ns2 outermost electronic configuration are called as S block elements. These are all reactive metals with low ionization enthalpies. They lose electrons rapidly to form +1 and +2 ions. Metallic character and reactivity increases on going down the group. P block elements. These elements belong to group 13 to group 18. These with S block elements are called representative elements. Outermost electronic configuration varies from Ns2 Np1 to Ns2 Np6. Elements of group 18 Ns2 Np6 are known as noble gases or inert gases. Elements of group 17 known as halogens and elements of group 16 known as chalcogens. Group 16 and 17 elements have high negative electron in their outermost shell to attain stable inert gas configuration. Non-metallic character increase on moving left to right in period, and metallic character increases on moving down the group. D block elements. These are elements of group number 3 to group number 12 in center of periodic table, also known as transition elements. General outermost electronic configuration of these elements is N-1, D 1 to 10, N 0 to 2. These are metals and they form color ions and show variable valencies and paramagnetism. Mainly used as catalyst. Zinc, cadmium, mercury with configuration N-1, D10, Ns2 do not show most of properties of transition elements. F block elements. These have two rows of elements at bottom of periodic table, that is lanthanides Ce Z is equal to 58 to Lu Z is equal to 71 and actinides Th Z is equal to 90 to Lr Z is equal to 103. Outermost configuration is N-2 F1 to 14, N-1 D0 to 1, Ns2. F block elements also known as inner transition elements. Metals. These are more than 78% of all non-elements. Means maximum elements in periodic table are metals and present in the left side of periodic table. These are usually solid at room temperature, meaning except mercury, which is liquid at room temperature. These have high melting point and boiling point. These are metallic, can be flattened into thin sheets by hammer, and ductile, can be drawn into wires. Non-metals. These present in the top right hand side of the periodic table. These are usually gases or solid at room temperature with low melting point and boiling points. Boron and carbon are exception. Most of non-metallic solids are brittle and neither malleable nor ductile. Metallic character increases down in the group. Non-metallic character increases from left to right in a period. Metalloids. Element, Elements which show character of both, that is metal and non-metals, are known as metalloids or semi-metals. Example: silicon, germanium, arsenic, antimony, tellurium. Now we are going to discuss periodic trends in physical properties. First is atomic radius. Atomic radius decreases with increase in atomic number in a period, because within the period the outermost electrons are within the same valence shell. Also, effective nuclear charge increases with increase in atomic number, result in increased attraction force between nucleus and outermost electrons. Atomic radius increases with increase in atomic number in a group because of filling of inner orbitals with electrons, which serve to shield the outermost electron from attraction of nucleus. So size of atom increases. As a summary, we can say that on moving left to right in a period, atomic radius decreases, while on moving top to bottom in a group, atomic radius increases. Ionic radius. On general, the trend of ionic radius is same as that of atomic radius. In ions, loss of electron or gain of electron may take place, while no change in nuclear charge. Size of cation A plus is smaller than its parent atom due to loss of electron, and size of anion A minus is larger than its parent atom due to gain of electron. So in simple, we can say that ionic radius follow the same trend as that of atomic radius, except its comparison with its own element, as compared to neutral element. Size of cation means cation formed by loss of electron, so it lost one electron, so it feel more attractive forces, so its size is smaller, while anion is formed by gaining of electron, so it there is an addition of electron which increases its size. Now we are going to discuss ionization enthalpy. Quantitative measure of tendency of an element to lose electron is known as ionization enthalpy. Ionization enthalpy is always positive. Second ionization enthalpy is higher than first ionization enthalpy. Alkali metals have lowest and noble gas have highest ionization energy. Ionization enthalpy increases on going left to right in a period, because it is very difficult to remove electron from left to right most atom, because it have a smaller atomic size, and decreases on moving downward in a group, because as we move downside in a group in a periodic table, the atoms or elements in the downside of the group have very less attractive force to be experienced by the outermost electrons. So outermost electron revolving around the nucleus easily get removed, so they have low ionization enthalpy. Electron gain enthalpy. When an electron is added to a neutral gaseous atom to convert it into a negative ion, the change in enthalpy in the process is given by electron gain enthalpy. So we can understand it with an example as x plus e minus, that is addition of electron gives x minus. It may be exothermic or endothermic reaction. Halogens shows exothermic reaction and have high negative electron gain enthalpy, while noble gases shows endothermic reaction and have lowest positive electron gain enthalpy. Electronegativity, the qualitative measure of ability of atom to attract shared electrons from chemical compound or chemical bond towards itself, is known as electronegativity. It generally decreases down in a group and increase in a period from left to right. Periodic trend in chemical properties. Trend in valence or oxidation state. The valence or oxidation state depend on outermost orbital elements, electrons, and or either 8 minus 1 or 8 minus number of outermost electrons. So it's a small dictation of classification of elements and periodicity in properties. You can download notes or PDF notes of this chapter from our website www.chemistrynotesinfo.com. Thank you to listening this episode. See you soon in our upcoming episodes.